We got one super quick thing to talk about. Questions on that? I don't suppose. No, you don't get paid. You wish. We wish. I wish I got paid. We'll circulate the info again on the forum and things like that. Yeah. Alrighty. Let me just shut this door. How are we going with the stream? That's fine. Can they see the slides and they can hear me? All right. Hi, online. The video camera will come up in a second. So last week we spoke about variables. Today we're going to talk about a little bit more with what we can do with variables. For those of you who got stressed because you saw the slides were out of sync, don't get stressed. That's my problem, not yours. But sometimes the term has, multiple lecture breaks and things, like public holidays. So the timing gets thrown off. So just because the timing of the slides doesn't match the timing of the lectures, it's not a problem. Okay. But we should get back into lockstep with the actual files. Okay. So let's do a quick little recap here. If we think about it, we've got the type, the name, and the value on that first line, right? Type, name, value. There's another example, this time it's a double. And we spoke about printing it. We can printf, so we call the printf function, we give it a string. Everything in double quotes is the string. And we spoke about this idea of placeholders. So %d is the decimal placeholder for the diameter decimal. And the %lf is the long float or the double placeholder for the pi variable. And so this will print out the diameter is 5, comma, pi is 3.141. Because the variables are passed in, comma separated, and they're put into the placeholders. Right? So that is creating and initializing variables and printing them out to the terminal. So if we think about printing, what's the opposite of printing? Reading. So we need to print information to the user. Sometimes we need to collect information from the user. And whenever we collect information from the user, we need to keep it somewhere. And if we're thinking about keeping data somewhere, that means we're using memory, we're using variables. So the way which we read information from the user is typically storing them in variables. So it's the alternative to printing. So printing uses printf, reading uses scanf. We scan from the terminal in the format the same way, and we read in some data from the user. We use the same format flags or specifier flags, so %d, lf, c, for example. They're used in the exact same way, which is grateful of that. And we have the introduction of this symbol, the ampersand, which we will revisit in detail soon. For today, I want you to think about it as it's telling scanf where to put the information. You'll see in the example in a moment. Here's the example. So we create an integer. What's it called? Input. We have a printf line, but this printf is just printing a prompt to the user. It's not doing anything, right? It's just a standard printf. It's not using that variable. And then we have the scanf here. So if we think about printf and stuff like that, then it logically sort of makes the same sense. We're scanning from the terminal. We're scanning an integer, %d, and where are we putting it? Into input. And it's that simple. Should we try that out? So I'm going to open up my VLab. Oh. Kind of need to move this here or something. Okay. Does it make more sense to be in the week 1 folder or week 2 folder for you guys? Okay, that was clear. Alrighty. Right, there's our little placeholder program. We've seen this many times. So if I'm going to read in an integer from the user, I need to create the variable that's going to store the integer. So I'm going to create an integer, so int, let's call it age. And you notice we don't assign anything to it because we're going to assign what we read in a moment. It doesn't really make sense. You could put a placeholder value here, but we're not going to do that. So how do I read in from the terminal? So I type scanf. Then what do I type? The type. So if we're reading an integer, what's the type? %d in quotes. So it's a format string technically. So that thing is a string that contains the format flag. And then I'm going to just pass in the name of the variable that I'm reading into with the ampersand in front of it. So that alone, unless I've missed something, I think the formatter is just slow. Or did I miss something? Sorry? Oh no, it was just super slow. Yeah. Yeah, I haven't got the prompt yet, but this alone will store an integer in the age variable. Now, if we ran this, what would happen? Yeah, like it would store it, but we would have no way of knowing. So why don't we? So number one thing, if you've got a scanf, you pretty much always want a prompt right before it. So by prompt, I just mean print out some instructions. So enter your age, like that. So we often group a print and then a scan. How can I prove that I read a value into age? Print it out. Why don't we print it out? Hey, you are %d years old, and I'm going to pass in age. And notice there's no ampersand there. But this will prove, hopefully, that age was put into that variable and we can print it out. So I'm going to open my nifty terminal here. How do we compile? DCC scanning.c output into program. Look at that, no errors. I run that. Okay, so what line are we up to right now? What line is executing? Whoops. There we go, that's what I wanted. Line 7, exactly. So we've just printed enter your age. Now, what's happened? Why hasn't the program finished? Yeah, but this is different behavior, right, than what we've seen. Every time we've run a program so far, we run it and it ends. It does the thing and then it ends. So scanf is waiting now for the user to input something. So it's actually halted the program. This is kind of new for us in intro programming in 1511, 1911. But if you think about any other program you've ever used, it stays open because it's doing things. All right, so enter your age. Now, so right now, actually, so what line actually are we up to right now? Who said 7? Who thinks 7? Who thinks 8? Yeah, that's right. We're waiting now for the scanf. We just ran 7. So I can enter 20. And then we continue on and we print it out. Hey, you're 20 years old. So that's sort of how easy scanning is.
What happens if you put like I'm banana years old?
As in if this wasn't if you didn't enter an integer? We'll talk about that a lot. Good question. So let's talk a little bit more about it. So there are a few gotchas with scanf. So if you scan an integer, it ignores white space. So if you type space, space, 5, space, it will only read the integer 5. It knows to ignore the white space, which makes sense because it's looking for a number. Characters won't do this because a space is a character. So it'll read the space, okay? So if we want to ignore space characters, you can actually put a space before the %d, which tells us to ignore leading white space characters. So typically in our labs and assignments, this is how we will have reading in characters. It's a little weird. It's just something to note. It's one of the quirks of C. There's no ways around it. Any questions on scanning? That's the introduction to scanning. No? We're all happy with it? All right. So we haven't spoken about constants yet, but the good news is that constants are super simple. They're like variables, but because they never change, it means they're super simple to deal with. It can be more efficient to store constants, which is typically one of the reasons why we use them. They don't need as much memory. And we have a different syntax to define them. So we don't use, int age, for example. That's how we create variables. And in C, typically, and definitely in this course, we make our constants completely uppercase to show that they're constants. You'll see this in many, many programming languages that you go on to write. Okay, so here's how you define them. You do hash define, the name of the constant, and then the value. So there's an example where we're defining pi as a constant. This is a classic constant because pi never changes, obviously. And you don't want to type in 3.1415 every single time you need to use the value pi. So you might just create a constant for it. And you do that. Let me just show you in code so you can sort of see it. We typically put them outside of main, outside of the functions. They're global constants. So I could say hash define, the maximum or the minimum. Oh no. The min age could be 18. And now I can do something with that minimum age. Cool. They're really simple. All right. So now we have values, we've got variables, we've got constants. We can print them and read them from the user. What else can we do with them? Well, commonly with numbers, we can do calculations with them. Obviously, this is useful. So if you need to calculate things or whatever, this is how we do that. So we have arithmetic operations or operators in most programming languages. Pretty much all programming languages. And in C, here are the basic 4 building blocks. We can add, subtract, multiply, and divide. The cool thing is that they work pretty much as you would expect. They also even follow a pretty standard mathematical ordering that we typically follow. So division and multiplication will happen before addition and subtraction if there are no brackets, for example. So that's pretty much like, do you still call it BODMAS? I don't know. What? That sounds wrong. It was BODMAS when I was in school. Why did they change it? Brackets of, anyway. So here we have some variables, right? How many variables are defined here? 3. How did you know that? I mean, you can just count the types because this means that there were 3 variables made. All right, so let's look at this. So we've got age, it's set at 28. The current year, 2023. And then I'm creating a new variable called the year born. And it's assigned the value that's returned when I subtract age from the current year. So that's an expression, that's a calculation. Do we need to sit with that for a second, or is this pretty smooth sailing? That's the fly. Any questions on this? So what's year born going to be in this program? Well, I'm not going to torment you through that. Simple subtraction. Anyway, and then we print you were born in the value year born, whatever that might be. No questions on this? Do we want to see a quick demo? Yep. Let's go back to our program. We ask someone for their age. We get age into a variable. We can keep building on this. And we can just, we can just do something silly here, but we can just say age is equal to age plus 5. So I'm reassigning age to be the value of age with 5 added. So if I run this exact same program after I compile it, and I enter 20, what's going to be printed? 25. So I did an arithmetic expression on age, and I stored the result back in age. What if I didn't store it back in age? Whoops. What would this do? Who guesses 20? And who guesses 20? Oh, ignore the warning. It still will run. And who guesses 25? Who guesses 20? Who guesses 25? So what are all of you? It's a yes or no question. Who guesses 20? Okay, and who guesses 25? I'm gonna go postal here. Probably shouldn't have said that. 20, because we didn't assign it back to age. And everyone that didn't put your hand up, I'm gonna get you. All right. Obviously, we can multiply, add, divide, and it works pretty much the way you'd expect, except for maybe dividing. There's some quirks with dividing that we'll talk about. You can in C do that. Whoops. So there is this operator. Whoops. What? Which also does the exact same thing. Oh my God, what's wrong with my keyboard? What is wrong with my keyboard? Anyway. They are identical lines. It's just a shorthand because it's a bit long to write out. But we don't have to worry about it. There is some quirks with dividing, especially around floating points, but we'll deal with those another time. Something worth noting, and you will need to know this for some of your labs and things like that, is that characters are just ints playing dress up. So the cool thing about a character here is that I can define the character and assign it the character B, right? Then I can just add 1 to it because it is an integer. And do you remember when we saw that ASCII table? If we find the letter lowercase b and we add 1 to it, what will that character be? C. And that will work exactly as we expect. So this is a fun note about characters. That's how they're represented. We spoke about this a little bit, but don't forget your limits. So data types have limits. It is easy to forget. So if we add 2 very large ints together and we try and store it in an integer, we're going to overflow, which will cause problems. This is not just theoretical. So this is an article about this exact same thing happening, an integer overflow, which caused an explosion on the Ariane 5. I think I have another example. The Boeing 787 in the operating manual has to be rebooted manually every 248 days because a counter keeps counting. And after 248 days, it gets too big for the container and it overflows. Which now the Boeing gonna send a hitman to me, their current trajectory. And Gangnam Style classically overflowed the view, was it the view counter? Yeah. So these are, multi-billion, trillion-dollar corporations making these mistakes. You will make them too, even though they are really simple. Another thing that causes huge amounts of pain to programmers is floating points, is doubles. Because there's no such thing as infinite precision in computing. There is in mathematics, but not in computing. We can't store infinite precision of a floating point. So something as simple as if you take 1/3 and assign it to a double, In mathematics, that is 1 point or 0.333 recurring infinitely, right? But in C, it's however much data a float can store. And so if you're doing some complex calculation that relies on that precision, you're in a lot of trouble. So you'd need to be aware of it. Okay. That would be embarrassing. Okay. Could be worse. Could be much worse. So remember that C thinks in data types. This is the part that will trip a lot of you up. So pay attention for a second here. This is really annoying. It annoys me a lot, at least. So let's say you're dividing two numbers, an integer and an integer. What do you think the response will be, the result? An integer, not a double. So if you divide 1/3 integers, you're not going to get 0.3. Let's prove that. I'll make a new program. All right, what do we think will be printed here? Oh yeah. All right, what do we expect to see out? Yeah. Why? Who said that? Why? Yeah, it's rounding down, I guess you could say as well. But do you see how that is incredibly confusing? That's how you can explode spaceships and crash airplanes. Seriously. Like if you're trying to calculate some trajectory and you're like, oh, I need to go down at a rate of 0.3 degrees, and you're doing something like this, you're in a lot of trouble.
Would like 4 and 3 be stored as 0 or 1? If you
Say that, oh, we can test it. So would 4 and 3 like this? So it's just going to cut off everything after the decimal point. So how do we fix it is the question. Do I have a slide on how to fix it? I guess not. So one way we can fix it is just by storing it in a float. I'm pretty sure that's the fix here. No, it's not. It's not right. I cast it? That's the only way, Angela? Yeah, okay. So the problem is they're both ints. So it's doing a division on the int. So it's always going to give back. It's going to lose the data here. Do we teach casting? I can't remember now. No? No, so you said. Like here. Yeah. Like this. Here. Oh my God. Is that actually the way we teach to do it? Anyway, so if you think about what this is doing, it takes, whoops, I didn't compile it. It takes the integer a, times it by 1.0, which will return a what? So yeah, an int times a float will be a float because you're getting floating point precision. And then it's a float divide an int, which will also get the floating point precision back. .333. There are other ways that are maybe cleaner to do it, but this is simple. Yes, if they were both doubles, you're fine. Yeah. It would always need to be a float. Otherwise, you'd just be throwing it away anyway. Yeah, yeah, exactly. But you can see this is a quirk of C, right? All right, that's that lecture slide. All right, now we go off to alrighty, control flow. Let's ignore that. And we've done an input output recap. All right. Okay. Now we're getting to a point where we can do useful things. So this is really exciting. Let's go back to our little recipe analogy, right? You've just made your cake, you've mixed the batter, blah, blah, blah. And then you get to the step where it's like, put it in the oven, yeah? Anyone bake a cake on the weekend? Someone? Yeah? So it goes, you get to the step where you put it in the oven, right? Everyone knows what I'm talking about? Let's keep the noise down, whoever's chattering. So you get to the step, put in the oven, and it says, if it's fan forced, do blah, blah, blah. If it's not, what's the other one? Induction? Conduction? Convection? Convection. Do something else. That's what control flow is. It's that simple. Control flow is controlling the flow of the program depending on some criteria. And the simplest way we refer to these is just if statements. You might have heard of if statements if you've done programming before. But if we think of programs as sequence of instructions, if statements allow us to, depending on some criteria, run different sets of instructions. And the way we do this is with this primitive called the if statement. You'll be using this for the rest of your life. So if always determines the result of a true or false question. So if we think back to our recipe, do you have a fan forced oven? That's a true or false question, a yes or no. If the answer is true, do something else, do something else. Or maybe there is no else. You know, else maybe skip it, go on to the next thing. So for an example, I can say, if some integer x is an even number, do something. So we need to talk about Booleans a bit before we can sort of continue. So C, we remember, is a really primitive language, and they like reusing things. So in C, true or false is pretty much the integer 1 or 0. 1 being true, 0 being false. But later in the language, actually, they gave us these handy true or false values. But they just still map over down to 1 and 0. But interestingly, C didn't ship with this. Oh, it's right. I've got it here. So if you don't include standard Boolean .h, you have to use 1 and 0 for true or false.
Does that mean true and false statements are stored as an integer?
Yes, Booleans are stored as small integers. They don't take up as much space as integers, because if you think about it, you only need 1 bit. But it means like you could have, you know, the false 0, add 1 to it, and now you've got true, right? It is a number at its core in C. Okay. So this condition we said for an if statement has to be a true or false value. So if I had if brackets 1, would these 2 lines of code run? Who thinks yes? Who thinks no? Why do you think no? Why do you think no? I've just lost everyone? So we said 1 is true if asks a question. If something is true, if I have a true value here, then I will do whatever is in the block.
Is it because we don't have an else statement?
We haven't introduced else yet, so let's not skip too far ahead. So this is the structure of the if statement. If something is true, do this block. So if I had a 1 here, and 1 is true, would the block run? Okay, cool. If I had a 0 there, would the block run? No, and therefore we've just controlled the flow of the program. And again, we have our handy brackets here. The braces are making a reintroduction because we need to know which lines of code are associated with the if statement and which are just part of the program. So here's that example. Here's an if statement. If 1, the condition was true, gets printed. So will this print anything? Yes. Yeah, it's always true in this case. It's not a very useful if statement, don't get me wrong. Here's another example. Will this print anything? Okay, good. Why not? False is 0, 0 is false. Therefore, the block will not execute. All right, so those two were pretty easy. Ready for a harder one? All right, now those were pretty useless questions because they're always true. Imagine if you read a recipe and it was like, if the day ends with Y, put it in the oven. What? So usually we have something that's dynamic that's part of our condition. So if we want to ask questions, yes or no questions, true or false questions, we need some operators to do that. So here's an example of one of them. But if just by using our sort of intuition, who thinks this will print anything? Okay, what are you intuiting those symbols to mean? Yeah, you've seen them before. You use them in mathematics. So if x is greater than or equal to 0, and we know it is because x is 5, that will simmer down. I don't know why I'm such big on the chef analogies. That will, well, in fact, the correct term is reduced down to true. And then if true, we do the block. All right, so what is this symbol and are there any more? Well, here they are. Again, they're all quite logical. Haha. That was funny. Less than, greater than, less than or equal to, greater than or equal to, is equal to, not equal to. So all of these things, all of these operators, they take the thing on the left, compare it to the thing on the right, and give you back a true or false, a 1 or a 0. Do you want a second to write notes on this slide? Any questions while people are writing their notes? No? All right. Oh. So the question there is a good question. Guys, let's keep the noise down so the online chat can hear us nicely. The question is, can you always ask one question? Is that basically what you're asking? Yeah, and the answer is yes. Well, yes and no, but you always need a true or a false in an if statement, no matter what. There are ways to chain multiple questions, but we haven't gotten to them yet. Okay, here's another really big gotcha. Okay, look at this slide very carefully, make a mental note of it. I promise many of you are going to come to help sessions with this problem. In all their wisdom, the people that designed C thought double equals should be equivalence, and single equals is what? It's a sign. It means put the value in the variable. But you can see how they're pretty close. So don't get confused there.
So double equal is equivalence?
Is equivalent.
Yeah, and the equal is just
Put the value in the variable. They're totally different. That's the problem. All right, here's some questions. Let's go rapid fire. Number 1, true or false? Number 2, number 3. Good. Number 4, 5, 6. Chaos. Who thinks true? Who thinks false? That's not what we heard. It's pretty simple. Characters, we don't even need to know the fact that they're integers, but if we do, they're two different values. Are the values different? True. So the answer is true. Do they not equal each other is what that's asking. Oh, you're just scratching. Yeah, okay. All right. Let's write some code. I'm going to copy my template. And this is a program that you can... What is wrong with that? I don't know what's going on. So this would be a program to code along with me with. So get your programming environment up, get VLab up, write out this starter code, and maybe just chuck your hand up when you've got this template written. So I know when to start. While you do that, I want to see if I can get the lecture chat up here. All right, I've got the lecture chat up. Why is it so small though? Can I make it bigger? Here we go. All right. Hi everyone online. Good to see you. Oh no. What just happened? Hello? Okay, are we back? Is that still streaming? Okay, good. All right. That was weird. All right. What is going on? Oh no, I think we are disconnected. I think I lost internet for a second. Can you just reconnect? That was weird. What is going on? Why does Outlook keep opening?